Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi. So today I'll be explaining regarding the lean design of alternative packaging cushion material for glass bottle using rice husk and coconut fiber. So without wasting time, let's get started. In recent years, rice husk and coconut fiber started to have substantial commercial value in the industry due to research being conducted on these agricultural waste as a new raw material consisting of high fibers and abundant resources. So this project is focusing regarding the development and design of glass bottle cushion by using rice husk and coconut fiber as an alternative packaging cushion material. The model is designed by using AutoCAD software, so the three different models of rice and coconut fiber were created in proportion of 100% of rice, 0% of coconut fiber, 50% of rice and 50% of coconut fiber, and lastly 0% of rice and 100% of coconut fiber. Each proportion is mixed with 25 grams of water and 225 grams of latex adhesive. The model is then being tested using drop test machine at 4 orientation and 3 heights to evaluate the performance of each model. The results from the drop test are compared and analysis are being done to select the most suitable material to be used as cushion material. So in order to identify the impact of cushion from different composition, drop tester model AD100 design series 4410 were used in accordance to the standard ASTM B5276 drop test of load containers by Freefall 1998. The main objective of this project is to produce and design cushion models for glass bottle and evaluate the performance of the cushion through a deep free fall test. To achieve the objective of this project, we have set several guidelines to facilitate and launch this study. There are mainly four scopes to this project. First and foremost is to obtain information about the theory of cushions that are appropriate for making rice husk and coconut fiber as packaging cushion material. Next, we are able to produce cushion materials from rice husk and coconut fiber. The third scope is to be able to design cushion models using AutoCAD software, and lastly, to conduct performance and durability tests through deep free drop tests through various orientations. The significance of this research, there are mainly 3 points. In Malaysia, packaging is an issue that should be emphasized. Why? This is because most of the material used to create packaging are non-degradable materials such as plastic and styrofoam. Process and site disposal requires high costs and can endanger the health of the population of local community. So in this study, rice husk and coconut fiber are one of the ingredients that can be used as an alternative material for packaging performance system. Rice husk and coconut fiber are waste material that have mechanical performance in application of composition. They are easily dissolved by the environment. Now, for the methodology, we can see the flowchart of this whole methodology of this project, where we start by selection and preparation of raw materials, then design and preparation of the mold. Once the preparation of the model is being done into three separate model, model 1, model 2 and model 3, then we can conduct the drop test based on the ASTM standard on various heights 77, 92 and 107 centimeter. After conducting the ASTM drop test, we can tabulate the data obtained and, and do the analysis and discussion based on the result obtained to decide which is the suitable material for cushion. So now I'll be going in detail regarding each of these flow. First and foremost, regarding the selection and preparation of raw materials. So in the beginning, we'll start by preparing the raw materials of rice husk and coconut fiber. So the coconut fiber is cut around 2 inches and ground using a grinding machine. The rice husk and coconut fiber is then placed on a drying machine about 80 degrees Celsius for about 3 days. This is to ensure the materials are dry from moisture. So now for the design and preparation of the mold. So for testing purposes, we use glass bottle as a product. So the cushion is then developed using AutoCAD software based on the measurements taken from the glass bottle itself. Alright, now for the preparation of the mold. So three different cushioning models are provided based on the raw materials of rice husk and coconut fiber. So each model's total raw material weight is 200 gram. So this 200 gram is divided equally between the upper cushion mold model and the lower cushion model. So on the next slide, we'll be showing regarding the three different models. So back to the preparation of the mold. So each sample model was mixed with 450 gram of liquid latex adhesive and 50 gram of water. So the process of selecting the weight of this adhesive and water is repeated several times to obtain results. So liquid latex adhesive is used to adhere the raw materials, while water ensures the mixture of raw materials and liquid latex adhesive is completely mixed. So after that, the ingredients are mixed perfectly and uh, put into the mold so that it has been prepared. So the mixture is then added in stages where 20 millimeter of diameter PVC pipe is placed vertically in the center of 102 millimeter diameter PVC pipe. So the mixture was added progressively to fill the gap between the two PVC until it reached the height of 35 millimeter. Pressure is then applied during the mixing to reduce entrapped air. So after pouring the mixture into the mold, you can place the model in a drying machine around and set it around 80 degrees Celsius for 4 days to ensure the cushion dries evenly. So after we have prepared the mold, we can now do the drop test. So to determine the package cushion performance drop test, we're going to conduct this drop test, where this drop test is being done in several orientations at several heights. So drop test is what is a drop test? So drop test is basically a test that drops where we drop a container from a load to determine its resistance to failure. Either it breaks or leakage as required to produce a container through the appropriate specification of the Department of Transportation. So the free fall test basically is a simple and quick method in order for us to determine the motion and critical acceleration value that from this critical acceleration value we'll use uh, we can collect the data. So based on the free fall test, we can see that the object will experience an increase in velocity when it's dropped from a certain height, and the velocity will be zero when the object touches the floor at the surface, which resulting shock. So this is the three different model concentration and its specification. You can see model 1, model 2 and model 3, and the specification whether it's using 100% rice husk or 50% rice husk, 50% coconut fiber, and the third model you can see it uses 100% of coconut fiber. For the analysis part of this project, we conduct the analysis for each model. So as we have known, there are three models overall. So the focus for the analysis part are made on the difference in the peak acceleration and the height of drop test. So the orientation position of each sample has been decided to achieve the peak acceleration value. So the drop orientation we have four. So from the table below you can see the orientation we have T, B, TE and BE. So each one stands for T is for the orientation on top, B is for the orientation on bottom, TE is for the orientation at top edge, and BE is bottom edge. So here uh, three different height you can see at 77, 92 and 107 centimeter, and in the table is the value for the peak acceleration. So basically, for overall, there are no bottle that broke during this drop test. So during the test on the 107 centimeter height, cushion model 1 and cushion model 3 is damaged, which model 1 during the top edge and bottom edge, while the model 3 during the top edge. So for model 3, the damage area is at the edge where it dropped. So based on our observation, this damage happens uh, because the glass bottle is pushed the inside of the cushion when they drop at the edge. This happens because most of the bottle weight is focused on the edge of bottle, which gives more impact at the edge. So the inside of this cushion is not capable to withstand the force, which result the bottle to break through the cushion. So the result GP you can see from around 22.46 until 23.88. So there is the value that is less than 22 maybe due to the instrumental error while we are experimenting. So this result can be more precise if the experiment is repeated for around 3 times, more times, around about 3 times, for example. So at the same orientation, of course, in the same height, so we can get the average of the data, and we can calculate and tabulate. So at the end of this testing, there is a chip from the cushion scattered when the impact uh, taken from the drop. So to create a good package, a good package system, loose fill materials such as packaging, chips, shredded material, newspaper, and others should be avoided. Thus, the sample is suitable for cushioning design, yet not suitable for packaging system. Here, here from the figure, with the 3 times of fall, the average peak acceleration is 23.34, 23.31, 22.82, and 20.59. So each of these is at the orientation of top corner, and bottom corner respectively. So from our observation, the model 1 cushion failed where the bottom corner of the cushion model was broken during the second and third drops at the bottom corner orientation. Still, this product is still in good condition since the cushion model has absorbed all the shock energy that occurs during the fall. So the highest peak acceleration that occurs at the top orientation with 23.877, and the lowest peak acceleration occurs at the bottom corner with value of 18.89. So for the peak acceleration, you can see the average value of 23 on top, bottom, and bottom corner orientation. Well, only the top corner has a very low average value, which is around 22.56, the peak acceleration. So at this time, there was no break in the cushioning model after the drop test. However, there is some damage to the corner of the cushion during drop in the top corner orientation. The bottom corner orientation displayed a low peak acceleration in the first test, but in the second and third test, the peak acceleration value was around the same range value in other orientation as well. So this may be due to some technical error, which has been done during the first fall, which I have explained previously. So in this figure, you can see the average acceleration value is slightly lower at the top corner orientation with a value of 21.31, the peak acceleration, while outer acceleration values are around 23.46, 23.58, and 22.95 at the orientation of top, bottom corner orientation respectively. So at the top corner orientation, you can see the cushioning model has broken in third test with a peak acceleration about 17.36. So the cushioning model has already suffered damage in the first and second test, causing the cushioning model to break in the third test. However, this product you can still consider it is still in a quite a good shape. So based on this figure, you can see the average of peak acceleration for the three cushioning model at a fixed height of 92 centimeter, and at the top corner and bottom corner orientation. So the average peak acceleration at the top orientation for model 1 to 3 are 23.34, 23.38, and 23.46 respectively. So for the bottom orientation, the average peak acceleration for models 1 to 3 are 23.31, 23.19, 23.58 respectively. So there's we can check the values of the orientation at the table. So based on this graph, right, we can see that at the top corner and bottom corner orientations of model 2 have a higher value compared to other models. So this high and stable value of the peak acceleration, which we obtained from the result, shows that model 2 is a complete model 2 is have a very high and stable peak acceleration value. So model 2, which is a combination of two composition of rice husk and coconut fiber, it has a high ability to absorb shock energy when it is dropped from a height and touches the floor surface. So besides that, the acceleration value of model 1 also shows a low acceleration value at the bottom corner orientation, followed by model 3 at the top corner orientation. So from the result that we have obtained after we have finished the analysis, so we can conclude that model 2 was selected as the best damping model in terms of the ability to withstand the impact force of free fall as a system damping. So according to the overall test finding, Model 2 offers the best performance in this free fall test, with peak acceleration value is a key factor in figuring out how well a cushion can support a product under constant stress. So this is due to loudness of cushioning system model, which has a high peak acceleration, and explain how it can buffer the applied shock force. However, as the sample is dropped more frequently onto the floor surface, it is the ability to absorb shock forces will decrease. So if it's dropped in an unstable shock like state at the upper corner orientation and lower corner orientation, the peak acceleration will also shows a minimum value. So next, regarding the longevity of the cushioning system increases with the value of the peak acceleration. So the longevity of the cushioning, as I said, uh, the longevity of cushioning system increases with the value of peak acceleration. So this phenomenon basically explains why cushioning system model has a higher average peak value and stronger characteristic when compared to other models. Uh, so now we can see that shock force is continuously applied. A cushioning material capacity in terms of strength, it will decline. So from this, we've determined that model 2 is superior to model 1 and 3. So finally, to rest my case, in a nutshell, I can say that this study is successful because it has achieved the desired objective of identifying the appropriate cushioning model by design using the lean concept for glass bottle for transport purposes through free fall tests. So the free fall tests are conducted to meet the complementary test specification. This test aims to evaluate the properties and characteristics of various materials and determine the performance of the best cushioning material that can work in the most optimal condition in different situations. So based on the data and analysis which we have collected and obtained, Model 2 is the best sample cushioning model. With that, I'd like to end my sharing session. Thank you.